Good morning, AOBI. This is Mr. Dunning. Stand by. I have a math lesson for you. Today's lesson, lesson 17, talks about the algebra of a circle. We're going to look at a circle centered at the origin, and we're going to look at the general case where the center doesn't have to be at the origin. We're going to learn the equation for a circle, but most important to you today is you're going to learn why it is the equation for a circle. To start off, we're going to begin with a circle centered at the origin, 0, 0, where the x and y axes meet. And in order for us to do this, what we're going to do is pick this one lonely little point, and we're going to follow it as it moves around the circle to see how we can express where this point is. This point will always be some distance over, and we're going to call that over. And it will also be some distance up. Now the key here is to recognize that this point is tethered to the center of the circle. It will always be a radius away from the center. Another key point, over and up meet at a right angle. So this will always be a right triangle, or no triangle at all, be a straight line, but it won't matter. You get an accurate result anyway. So given this, we're going to use Pythagoras to come up with the equation of the circle. Ready? In a right triangle, we always have the relation that the sum of the squares on the two legs equals the square on the hypotenuse. So we can write this piece squared over squared, and this piece squared up squared is the radius squared. Now generally when we talk about over, because it's an x distance, we use x. Generally when we talk about up, we're talking about a vertical distance, so we use y. When we plug those in to this, we get the Pythagorean equation describing a circle. X squared plus y squared is the radius squared. That is the equation of a circle with its center at the origin. Now, what would happen if our axis system was somewhere else? Say, over here. Clearly, we have the same circle, and this picture that we drew is still good, almost, because this green piece here is over, and if we use this value of x down here, we're going to get this whole piece way too big. Up here, well, same song. If we use that value of y, we're going to get this whole piece. And when we do that, x squared and y squared are not going to describe where this point is. Bummer, huh? Here's what we need to do. We're going to give this circle center the coordinates h over and k up. So, that's h over and that is k up. Now let's see what that does for us. This green piece here, projected down onto the x-axis, is that piece. Well, that piece isn't x long. That's the x value of this. But the green piece is going to be x minus h. So this piece that we called over is x minus h. The red piece here, projected onto the y-axis, is right there. And clearly, if we use that value, it's wrong. We need this piece, and that piece is going to be y minus k. Now, when we put these into the formula, we come up with the equation for a circle anywhere on the graph. The quantity x minus h, this piece, squared, and the quantity y minus k, this piece, squared, is the radius squared. That has not changed. So, if we go to our original over, if we go to our original over and up, you can see that this is the correct expression for over. And this is the correct expression for up. That's why the general form of the equation the general form of the equation quantity x minus h squared and the quantity y minus k squared is the radius squared. And now you know the equation of a circle any place. You say, well, what if it's at the origin? Well, h would be 0. K would be 0. And x minus 0 would just be x. Y minus 0 would just be y. And so even if this circle has its center at the origin, you can still use this form of the equation. We're going to look at a couple of examples. In example 1, the task is to find the equation of a circle centered at 2 over and 3 up and having a radius of 4. Now the key here, to do this correctly, that 2 is h. That 3 is k, and that is our radius Now, what we're going to do is we're going to take those numbers and we're going to plug them in over here. Now, don't get creative. Just take the numbers and plug them in. Here's how that works. The equation of the circle, quantity x minus 2 squared, and the quantity of y minus 3 squared is the radius of 4 squared. I can't encourage you enough to not get creative. Just plug the numbers in. Let's do one more example. In example 3, the circle is centered at minus 1, 2, and has a radius of 5. Wake up there, dirtbag! That minus sign, we need to learn how to do that. We're going to put it into the equation over here, just like that. I told you to don't get creative. Here's why. That minus 1 is the value of h. Now this minus sign was in the formula to begin with. The minus 1 is h, so the minus sign that was in the formula to begin with stays. And the value of h, minus 1, goes right there. Now, minus a minus, guess what? That's a plus. So our equation becomes x plus 1 squared and y minus 2 squared is 5 squared. We got that by putting the value of h right there, like we always do, and realizing that minus a minus is a plus. In example 4, we're tasked with writing the equation of a circle centered at 1 minus 2 with a radius of 2. Once again, last time I'm going to say this, don't get creative. Take these numbers and put them in over here. H is 1. K is minus 2. Radius, 2. Now, this stays x minus 1 quantity squared, but this guy has minus a minus, which becomes a plus. So we have y plus 2 squared is the radius squared. That's where we get these pluses. Remember, the minus sign was in the formula to begin with. That stays. If the value of h or k is a minus, that gives us this. And minus a minus gives us a plus. Final equation. Now, in number 5, I'm giving you a problem to do, and I want to see it in your notes. It's going to be a little different because you're going to have to take what you learned so far and use it. In problem 5, it's an example, but it's also a problem, and I want to see this in your notes all worked out. You have this beautiful circle here, center, and an XY axis system, x-axis, y-axis, with numbers on the axis system. Your job is to write the equation of this circle. You're going to have to use everything that you know, but you can do it. Tomorrow, we're going to continue our talk about the algebra of circles. The algebra of circles. Make it a great day. We'll see you tomorrow.